Okay, we're going to take a look at solving a kinematics problem. So we'll take a look at this one that I've got from physicsclassroom.com, and you can see the link there and access more questions as needed. So this one is kind of cute. It says, I am a Hurrian is approaching a stoplight, moving with a velocity of 30 meters per second. The light turns yellow, and Ima applies the brakes and skids to the stop. So clearly we have acceleration as we see here in the question. So we're going to solve it with our acceleration variables. So let's write down the 5 acceleration variables and populate this information. So we already said that Ima is traveling at 30 meters per second and comes to a stop. And then later on in the question, it says that Ima is accelerating at -8 meters per second squared. And later on, after that, they say determine the displacement. So we determine the displacement. That means we're not asking for time in the question, and we don't have time given in the question. So let's take this information that we have and what we're asked for and identify that. And that says to us, let's use the formula VF squared equals VI squared plus 2AD. And that addresses the the variables that are given and the one that we're looking for. So if we're solving for displacement, we manipulate this equation and divide by 2A. And then our next step is to substitute. So let's substitute into this equation our final velocity of 0 because Ima comes to a stop and starts at 30 meters per second. But remember, this is all squared. And I'll put this in brackets because it's all divided by 2 times the acceleration. Okay, so take a moment and solve for this. Use your calculator. So 30 squared, divide by 2, and also divide by the -8. So remember that 30 squared is going to have a negative value. So this works out to a negative divided by a negative, so a forward displacement, which is a positive displacement of 56.3 meters. And we want to show that in 3 significant digits. So there's our final answer. Now we can also look at this graphically. So if we were to sketch graphs of a position time graph and a velocity time graph of this motion, what would it look like? So we know that Ima is traveling at 30 meters per second and then comes to a stop. So we have to have an accelerated motion graph for position time, which is a curve, with a high velocity that goes to a 0 velocity. So you know that the tangent of this line shows a high velocity, and then eventually it will go to 0. So the slope of that line would be the velocity. We don't know where, as far as position goes, this person starts, so we can just sketch the graph with that curve. Then we want to show that Ima is traveling at 30 meters per second and comes to a stop in that same period of time. So we show 30 meters per second up here and 0 meters per second down at the bottom. So there's one example of solving a kinematics problem. Make sure that you are identifying your variables right here. Then choosing your equation, manipulating your equation, substituting. Oops, I got a bunch of lines going on there. And then getting your answer with the correct significant digits. It's always nice to be able to take a look at this aspect here so you can understand what this problem would look like graphically. All right, that's everything. Till we meet again.